examples of applications and visual inspection and quality of pultruded profiles. Talking about pultrusion, the introduction, it's highly used in the US, Europe, and Asia. Pultrusion technology is more and more present worldwide, and it offers innovative solutions for different segments. In Brazil, we have been following a growth in the manufacturing of pultruded profiles, particularly in agribusiness, in industry and civil construction. Protrusion comes from pull and through. So talking about the process, we have a pultrusion machine. All the steps for you to manufacture a profile starts at the roving, and then you have direct roving of fiberglass. You have fiberglass mats, preforming, and guides for the correct shaping and for entering the mold. We have the impregnation bath, where we have the resin, the surface mat. We have the mold heated at high temperatures that will give the profile, the temperature control, the pullers who are going to pull this profile. Our cutting device, according to the design, it has its predefined size and at the end the pultruded profile. I'm going to show you a video. If you don't know the process, you can have a good look at it. Pultrusion. So first of all, we have the bath with the resin, distribution of the fibers, direct roving. Then you have impregnation. The fibers go through impregnation in resin compound. You have the resin, the additives, the catalysts, the pigments. So if it's taken by this guy, this heating mold is divided by zones, entering, lead, exit. So it could be at different temperatures. The pulling, we have hydraulic or mechanical in order to pull the profile. And also ready for the cutting. All right. So I'm showing you a little bit of the process. And what are the main characteristics of the pultruded profile? Its mechanical strength compared to steel. It can replace concrete, wood. It's very used in industries, plants, structures. It has low density. It's very light, low weight. Manufactured from fiberglass, carbon fiber, or aramide. It's 75% lighter than steel and 30% lighter than aluminum. It has a corrosion resistance, so it doesn't oxidate. We have it's insulating. It's thermal insulator, and it doesn't transfer. And it's an electrical insulator used for power, telecommunications. There's an excellent dimensional stability, low coefficient of the dilation. It's homogeneous product, free of cracks. And the use of the surface veil gives you a good finish. It's highly durable compared to steel, concrete, and wood. And if you paint it with PU paint, you can make its life longer.
It's very easy to machine and to install. It's a very lightweight product. You need only a saw or a drill for adhesives, and it's very easy to handle, therefore, and easy to install as well. Looking at the raw materials, looking at the part of resins, we have isophthalic, orthophthalic, terephthalic, and vinyl ester. With regard to isophthalic resins, as well as the ortho and vinyl ester, they have to be highly reactive. They need to have a rapid production cycle, production of the wetting of fibers, very shiny, easily admit the fillers. The ortho and terephthalic, they have to be very impact resistant, but they are not very resistant to high temperatures. The vinyl ester resins have better rust resistance or corrosion resistance and work very well under high temperatures. The mineral fillers, which are widely used in the process, usually at limited quantities, because otherwise you do not have a good impregnation of the reinforcement. It can go up to 75% filler. The calcium carbonate fillers are the most widely used, and you also need a characteristic of auto or self-extinguishability. For the release agents, the main characteristic is to avoid the compound adhering to the mold. Calcium or zinc stearates are most widely used. In terms of the curing agents, these are organic peroxides. Dibenzoyl peroxide, BPO, in paste form, 50%, and TBPB, tert-butyl perbenzoate. They can be used in combination or in isolation. So the reaction starter is applied, and then the proportion is usually 3 BPO to 1 TBPB. For pigments, both organic and inorganic colored pigments can be used. We work only with organic pigments, which are free of heavy metals like lead, and they can be used either as powders or pre-dispersed pastes or vinyl esters, and they can be reactive or non-reactive. Talking about the reinforcing rovings and capes, rovings help you provide a mechanical structure, especially longitudinally, and for transversal resistance, the mats. And here we see this image from within. We have a continuous roving which gives it longitudinal strength, and the mat, which is glass fiber or could be carbon fiber, which is a transversal strengthening factor. Molds, also known as the matrix, are built of stainless steel. Not just any one, it has to be a carbon alloy, which is has high tensile strength. It has to withstand the heating and cooling processes. They're usually bathed in chrome to facilitate the freeing of the piece, and they also need to withstand deformation and also withstand abrasion caused by the mineral fillers and also the fiberglass. Each type of profile has its own type of mold. It could be conic or I or H shaped. Each type of profile has its particular mold. To talk about orthoterephthalic resins, we have Polylight 10-82205 and Polydyne 4018. These are non-saturated polyester resins which are non-accelerated. They're very polymerizable and they're highly reactive. The main features are good mechanical properties, particularly impact resistance. They accept mineral fillers and they are more affordable compared to isophthalic resins or vinyl ester resins. Applications for crossbars on utility poles, stairways or ladders for telecoms, and also window casings. The physical chemical properties vary from one to another. On the left we have the specifications of 10822 and on the right 4018. In terms of Brookfield viscosity, they're very similar, 750 to 850 or 850 to 1000. Dry matter, 64 to 67 for the 10822, 65 to 69 for the 4018. Gel time, similar, from 4 to 6 minutes. TMC, minimum cure time, 6 to 8 minutes. The exothermal peak, 180 to 210 Celsius. And HDT, thermodistortion time, 90 degrees. And the catalysis system is 2% of dibenzoyl peroxide, BPO 50% paste. For isophthalic resins in our portfolio, we have Polylight 31447, Polylight LP8847. These are non-saturated polyester, isophthalic, polymerizable resins which are highly reactive. They have high and medium viscosity, and neither of them is accelerated. Features: they both have excellent mechanical properties, 110 degrees of HDT and good corrosion resistance. They're used widely in aggressive settings, for example for acid or base media, for example guardrails and railings, beds for cables and connections, and also the structure for solar panels. The physical and chemical properties, it's the same concept as before. On the left, 31447 and LP8847 on the right. 31447 is more viscous, is 2800 to 3300 versus 300 to 500 in the case of LP8847. Dry matter, there's a difference. Solids, 69 to 71 versus 54 to 56%. Gel time, 5 to 7 as opposed to 6 to 8. Minimum cure time, 6 to 9 minutes versus 8 to 11. Exothermal peak, similar, 180 to 210. And the HDT, 110. Once again, it's the same catalytic system, 2% DBPB. BPO rather. Vinyl ester resin, it's a premium resin, low viscosity, non-accelerated. It's Dion 9102. Excellent mechanical properties, excellent performance in corrosive settings, excellent stability. It has a lengthenable or it's stretchable. For example, working in the setting of hydrochloric or sulfuric acids, for example, excellent stability. Its shelf life is 12 months. It's a liquid resin. And in the process, we have the resin compound, and normally you have a residue left in the bath, which continues in the next day's process. Depending on the resin, it's highly reactive in itself. The resin polymerizes, so it is highly stable. Applications for rebar, for example, glass fiber rebar, structures and platforms. Again, the physical chemical characteristics. Viscosity 280 to 350 CPs, dry matter 57 to 58%, gel time 7 to 9 mins, minimum cure time 9 to 12 mins, exothermic peak 180 to 200, and HDT of 105 degrees. Here are some examples of the applications. For example, railings on a walkway and also on an oil platform. Here we have structures, comparisons with steel. We see severe rusting on the left, which has compromised the whole structure. And for glass fiber, the structure on the right is still intact. With regard to electricity compared to stainless steel, for example, cable trays on the left, we can see corrosion and oxidation, but with glass fiber, everything is still in good repair. In architecture and urban work, we have before and after photographs compared against stainless steel. So, for example, protective railings, also very useful for the railings of bridges in shore applications. Other applications, for example, swimming pools which are heated. Sometimes you have chlorine added. Pultruded profile is the right option. And also you have pultruded grills in this channel or gutter. And finally, quality and visual inspection. There's a standard, an STM standard, which assesses or helps the end client has to carry out a visual inspection of what they're receiving to see whether the profile is in good repair to be applied in their design. So the visual inspection covers these points, which can all be defects: surface porosity. And normally there's a large number of small pores on the profile's surface, and to accept or reject this, provided that the maximum size is up to 2 millimeters and 0.5 mm in depth, because that's really an aesthetic issue more than anything else. In terms of cracking, separation, but there's penetration below the surface of the product. When it's unacceptable, this defect will affect the operating performance of the structure. With the lack of resin or dry fiber, this is where fibers have not been completely impregnated during pultrusion. It's unacceptable because it affects the structural functionality. And peeling, where small plates or fragments, flakes or fragments come loose. And this is more of an aesthetic defect. The transformer themselves can, for example, remove these flakes with a spatula, as long as no exposed fibers are caused by that. Fading or discoloration. there's some stain or area which has visibly changed color straight after fabrication. It's acceptable, but depending on the case, you may need to overpaint it with PU, but it's aesthetic. Ruptures, cracks, and these are and fissures. These are results of damage during to the pultruded profile, and that's not acceptable. So just to sum up, pultrusion seems simple, but it's not easy. Many sequential activities have to be carried out accurately. Good profiles depend on good plans and good choices of reinforcements and resins and additives, as well as planned and controlled processing. The use of PPE is necessary. The company should consult our workplace safety team. Here are some examples of the PPE that's usually used. The manufacturer or transformer should ask the manufacturer for documents concerning the products. We have a technical spec sheet and also the safety data sheet with training and recycling offered to employees. Here are, with regard to the Reichhold, we took part in the pultrusion committee, Almaco. So we have the manual on the guide to installation maintenance of pultruded structures, the purchasing and inspection guide for the pultrusion market, and recently we took part in a manual on applications of composites in building and construction. These are available on the Almaco platform, which is the Latin American Committee for Composites. Thank you very much. Thank you very much for your attention. If you have any queries, thank you very much. Does anyone have a question for Christian? Where's your stand? We're here with VI fiberglass. We don't have a Reichhold stand here, but we're here throughout the next 2 days at VI. Or Christian will be there if you would like to speak to him. Any queries? Thank you very much. Congratulations. Thank you very much for this opportunity. I hope you all have an excellent day and an excellent trade fair.